What's up, math scholars? Mrs. Harp coming at you with a math video. We're learning 7.4, sums of infinite series. Doesn't that sound crazy? We're going to add up an infinite amount of numbers. Woo! So who's excited to do this? Big, big numbers. Yeah! Woo! Outside class. Put inside classes. Class. Alright, so let's talk about what a partial sum is before we get crazy and add up an infinite number of numbers, infinite amount of numbers. We're just going to add a partial sum. So it's up to you whether you write the definition down. Some people love definitions, some people just read them and move along. But the sum Sn of the first n terms would be called a partial sum. The partial sums of an infinite series might approach a limiting value, or they might not. And it all depends on what that common ratio is, the R value. So today it will be our goal to look at those R values and just make sure that they are less than 1, or that the absolute value of them is less than 1. If they're too big, you won't be able to find infinite series, infinite sums. Alright, so we're going to try this one. It says, consider the infinite geometric series. 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. See, the numbers are starting to get smaller and smaller and smaller. This is one where we actually would be able to find the infinite sum. Let's write down the key points from yesterday. What is the A value? A1. And what's the R? 1/2 would be A1. In R, do 1/4 divide by 1/2. It's a half. 0.5. So here's how we're going to do partial sums. I'm going to make a chart to organize myself. And the values of 1 through 5 is what they're looking for. This basically just means find the sum of the first term, like only one term. What is the sum of only one term in the series? That would be this guy only. That's just going to be a half. 0.5. We'll do decimals. Then they're saying find the sum of the first two terms. So that partial sum would be, what's the sum in the green box? So do 1/2 plus 1/4. 0.75. Make sense? It's a partial sum. So my next partial sum is, what's the sum of the first three? So what's the sum in my blue box? So add that 1/8 to your previous answer. 0.875. And then my next one is, what is the sum of the first 4? So what's the sum of everybody in that black box? And then my last one, what is my sum of my first 5 terms? Or the sum in the pink box? 0.96875. So we can keep going all day long. We can find our partial sum of the first 6, partial sum of the first 7, partial sum of the first 8. We can go all the way to 100. We can go all the way to 1,000. But guess what? Your sum is approaching a limiting value. Any guesses what our sum is approaching? What? Just say it louder. 1. It's 1. It's approaching 1. So the sum of the infinite amount is actually going to be 1. Then we have a mathematical way of getting that, we'll get to shortly. But we're just kind of doing a demonstration thing now. Yeah?
What was the
No. So it's very rarely 1, actually. Yeah. Alright, we're going to try one more partial sums before we jump to the formula for infinite sums. So let's just go ahead and identify key features of this series of sequence of numbers. It's supposed to be an R. What is our A1? What is our first term that we're seeing? 2/5. And what does it appear that they're multiplying by? I would look at the top first, I would look at the bottom second. So what are they multiplying the top by? And what are they multiplying the bottoms by? How are they going from 5 to 25 to 125? So 2/5 is the constant multiplier. That's crazy. That's the second problem in a row that our A1 and our constant multiplier were the same number, isn't it? That's rare. It's just a coincidence. Alright, we are gonna, it says find the partial sums for n values 1 through 5. 1, 2, 3, 4, and 5. So the sum of the first term would just be this number. I'll go ahead and put these in decimal form, just so we can see what's happening easier. 2 over 5 would be 0.4. The sum of the first two terms, that would be these two guys. What would that end up being? Anybody get it? I got 0.56 as well. Sum of the first three terms, that would be these three guys. Yeah, that's what I got. 0.624. Sum of the first four guys would be these four. Get ahead of me. Oops. You got 0.6496. And then sum of the first five, that's all the five that you see listed above. All right, any guesses what our limiting value be if I continue with this sum? What number I'd approach? 0.7. It's 0.66. Or 2/3. So right now we're just guessing, we're just doing hypotheses. In about 2 seconds I'll be giving you the formula and you can get that sum just by typing it in the formula. All right, the moment you've been waiting for, here's the formula that can help you find the sum of an infinite geometric series. So keep in mind, if you would be seeing the series, it would look something like this. Add the numbers from term 1 to term infinity, and then they would give you the formula in geometric format. You all know what A1 and R is, right? Same as yesterday. A1's first term, R is constant multiplier. All right, the example I put up here is a great example. They want us to find the sum from term 1 to infinity. The thing you want to do, though, before you continue on your journey is just verify that your R value would be less than 1. The absolute value of the R value would be less than 1. So this is my first term, 2. This is my R value, 4. This is way too big, right? There's no way this could have a sum, an infinite sum. So you would write no sum if you would see that your R value is too big. Make sense? Makes sense. It's just too big. The numbers would grow too fast. We'll do one that you actually can do. Let's try this one. So it's clearly infinite. You see the little infinity sign on the top. It's got a first term of 5. It's got a common ratio of 0.8. Is 0.8 an appropriate size R value? Yes, it's less than 1. The absolute value would be less than 1. So we can go ahead and use our new formula we just learned. Correct. There would be no sum. It would be too large. It would be like infinite. All right, so I just wrote down the formula we learned today to use on these infinite geometric series. Let's plop the numbers in the correct spots. What's going to go in for A1? 5. Do you like that idea? What's going to go in for R? 0.8. If you want to type it in all at one time, because it is tempting, you must use parentheses right here. So go ahead and try figuring that one out. 25. That's what I got. Yeah. Here's our next one. We'll probably only do like 2 or 3 more and be done. Let's identify key features of this sequence. What's our first term? What's our common ratio? So the easiest way to find it is take a number on the right and divide it by the number on the left. So you could do this divided by this, or you could do this divided by this, but it is negative 0.75. Negative 3/4. Huh? Yeah. Everybody on board with how we got that? You would do the negative 3/4 divided by 1. Or you could do positive 9/16 divided by negative 3/4. They both give you that. Okay, is the R value an appropriate size to be able to find an infinite sum? Yep, perfect. So let's just use our formula. I'll jot it down for the people watching the video. What's going to go in for A1? 1. What's going to go in for R? Negative 0.75. Make make sure you do a minus a negative. It's very essential. The answer's kind of yucky if I remember right, so I clicked math enter enter after I typed it in and make it look nicer, make it a fraction. I got 4 seconds, so let me know if you can get that or if you're having trouble. Okay. Hey, I want to show you this one because there's information like hard to find. So you know how I normally say let's look at this and share with one another what A1 is and what R is? Ooh, what do you think about? There's like not 2 numbers appearing. One's invisible. There is an invisible 1 living right about here, and that's your first term. Okay, so our first term is 1, our constant ratio is -1/2. Is your R value appropriate size for an infinite sum? Sure is. So let's do this formula real quick. A1 goes on top. 1 minus R goes on bottom. Go ahead and figure out what that is. Two-thirds? Awesome. Yep. All right, we have one last problem to do. It's a word problem, okay? Then we'll be done. Hey, while I'm spacing through, is 5/4 an appropriate sized R value? No. So you would write no sum on that one, okay? So our word problem is our pendulum problem. A pendulum is being released to swing freely back and forth until it stops. So it's kind of like an infinite swing. It says it travels 18 inches on the first swing, and each successive swing, 80% of the distance of the previous swing. So what's A1, and what's our constant multiplier? Is that an appropriate size? Yes. Perfect. So let's find the infinite sum, and that will be the total distance the pendulum swings before it stops in inches. So A1 goes on top, 1 minus R goes on bottom. Type that in. That's how long it swings. Has anybody seen those pendulums? Like I think they have it at like Canton McKinley Museum. It swings and knocks the pegs down. They had one at the museum in Pittsburgh I went to. All right, what did we get? Last problem. 90 inches is how far this thing is swinging. Okay. Hey, so thanks for watching the video at home, everyone. We got done in 12 minutes. Awesome, awesome, awesome. And the homework is a worksheet. If you go on the notes, the worksheet's located at the very end. Like if you're at home sick today watching this, just go on the notes in Polaris. You can find it. And everyone in class, I'll be giving out a hard copy. Goodbye.